Okay, so for number 1, it says explain how the figure illustrates each statement is true. State the postulate that can be used to show each statement is true. We're going to focus on the postulate actually. This says that planes O, so this plane right here, and M intersect at line R. One of the postulates, the one that I had trouble drawing, was that two planes intersect at a line, and here it's showing it here. Plane O and M intersect at line R. So, in terms of explaining the postulate, two planes intersect at a line. I'm going to try to abbreviate. Two planes intersect on a line. The next one says line P lies in plane N. So here's line P, and it lies on plane N. The postulate for this one is if 2 points lie in a plane, then that line is on the plane. And again, trying to abbreviate as best I can. If 2 points lie in a plane, then the entire line lies in the plane. Okay, then 3. It says determine whether each statement is always, sometimes, or never true. Explain your reasoning. So again, we're going to keep going back to these postulates and using them to answer the questions. So it says 3 collinear points determine a plane. Well, 3 collinear points determine a line, but not a plane. They would have to be non-collinear to determine a plane. So this is never, because 3 non-collinear points determine a plane. So they'd be non-collinear would make a plane. Number 4 says 2 points A and B determine a line. That is always true. According to the postulates, through any 2 points, there's exactly one line. Through any 2 points, there is exactly one line. Number 5 is a little bit more challenging because it has you kind of combine concepts. A plane contains at least 3 lines. This is actually always true, and I'll draw you a picture to explain. If you have 3 non-collinear points, it makes a plane. But for every 2 points, there's a line. So it's saying that a plane contains at least 3 lines. Well, we know it contains 3 non-collinear points, but look, for every 2 points, there's exactly one line. So we have a line here, we have a line here, and a line here. So yes, there is 3 lines. Number 6. Again, we're using postulates to explain whether it's true or not. G and P are collinear. So I see point G and P. Remember, any 2 points are collinear, whether they have a line drawn or not. You could always draw the line if you wanted to, but G and P are collinear because through any 2 points, there's exactly one line. 2 points. I'm going to start abbreviating. There's exactly one line. 7 points D, H, and P are coplanar. Well, looking at it, D, H, and P, they're non-collinear, and yes, they fall on the same plane, so yes, it's true. Through any 3 non-collinear points, there is one plane. I know I'm kind of losing your attention with this. It's not very exciting. 8, it wants us to do a paragraph proof. I'm going to save the proofs for latter lessons, but here's what you need to know about proofs because it's a question on the homework. A proof with a paragraph proof. So a proof where you write a paragraph is a paragraph proof. That's one of the questions on the homework, just in case. Okay, I'm going to have you get on Schoology in a minute using the laptops. Before you do that, just to let you know, Schoology's been a little bit glitchy. For whatever reason, it's not grading your homework assignments right away. It'll show you how many you got correct, but then when you look at your test quiz score, it doesn't show the accurate score. So if there's a delay in it posting your accurate grade for your homework, that's normal. With this, as much as it's simple, it can also be challenging. So as you have questions, please raise your hand so I can help you get a good score on that homework. Cool? If you finish the homework, use the time to work on Khan Academy. You should have a good chunk of time to do both today. So at this point, you can get your laptops, bring them to your seat. Make sure you're grabbing your laptop